Question number 36. A sinusoidal voltage is applied to a pure inductor and we are asked to find out the waveform of the current. Now we have this voltage waveform V equal to Vm sin omega t applied to a pure inductor. So from 0 to pi, the current in the inductor will be increasing, and at pi the current is maximum. And what happens at pi? That means at pi the instantaneous input voltage reverses, but L di by dt is more negative than the instantaneous value of input voltage. Hence the current starts decreasing and the current becomes nearly 0 at 2 pi, and again it continues to increase and it reaches a maximum value at 3 pi. So we have the current here as the inductor current here as this waveform. So this waveform, the continuity of this current will depend upon the value of inductor. If the value of inductor is very large, then this ripple will be minimum. Hence the output waveform will be of the form Vm by L into 1 minus cos omega t. So this will be the value of inductor current. Most of the people get confused that whether here it will be, that means at pi, whether it will, the inductor current will get rectified or something. It won't get rectified. What will happen is at pi the value of L di by dt is more negative than the instantaneous value of input voltage. Hence the diode will keep on conducting from pi to 2 pi, provided that means at the same time the current starts decreasing. So the diode is conducting for all the parts of the waveform. That is, for a diode to conduct, either the anode voltage should be greater than the cathode voltage, or in other words it can be said that if the cathode voltage is more negative than the anode voltage, then also the diode will conduct. So this is the case where at the negative half cycle the cathode voltage is more negative than the anode voltage. Hence the diode will be conducting, at the same time current will be decreasing. Hence the correct option is option D.